In the next three examples, we want to find the x and y intercepts for an equation algebraically, meaning not looking at the graph of the equation, just pulling that information out of the equation itself. We'll start off in example 5 by finding the y-intercept, which we probably likely already know how to do because this equation is written in slope-intercept form. We just have to identify that value for b, which in this case is -3. So our y-intercept would be 0, -3. If we didn't know that, or just to demonstrate the idea of how we're going to go about finding intercepts, what we could do is rewrite the equation, and remembering that when we find an intercept, the other coordinate, the other variable is always equal to 0. We substitute in 0 for x, and then determine what y would be. So we would get y is equal to 0 minus 3, or -3. Again, we didn't really need to do that since this equation was already written in slope-intercept form, but we will need to apply that idea to be able to find the x-intercept. That's not as obvious. Keep in mind the other variable is always equal to 0 when we find an intercept. So what we would do in this case is plug in 0 for y. So 0 would be equal to 3/2 times x minus 3. So we would add 3 to both sides as we start trying to solve for x and get 3 is equal to 3/2 x. And then in our last step, we would multiply both sides by the reciprocal, 2/3. On the left-hand side, whether we multiply together or reduce first, those 3's would cancel. We'd end up with 2 is equal to x. So we get an x-intercept in this case of x equals 2, y equals 0. Again, what we did there was set the other variable. Since we wanted to find the x-intercept, we set the y variable equal to 0, and then solve for x. In example 6, we have another problem that's given to us in slope-intercept form. We can identify that y-intercept very easily by looking at that value for b, and we know that our y-intercept would occur at 0, 6. But then to find the x-intercept, we would need to substitute in 0 for the other variable, so we would plug in 0 for y. That will be equal to -2/3 x plus 6. We'll subtract 6 from both sides to get -6 is equal to -2/3 x. And then we'll multiply both sides by the reciprocal of that fraction. That should be a -3/2. -6 over, or I guess we could just say 6 over 2 will reduce. So we'll end up with -3 times -3, or 9 is equal to x. So our x-intercept will be at the point 9, 0. Now in example 7, we don't have the shortcut like we had in examples 5 and 6 for finding our y-intercept because this equation is not written in slope-intercept form. That gives us two ways to approach this. We could first solve for y. We could rewrite this equation in slope-intercept form, or we could just tackle it more directly. And that means that in order to find the y-intercept, we would set the other variable, x equal to 0. That would leave us with 8y is equal to 40. And then if we divide both sides by 8, we would get y is equal to 5. So our y-intercept in this case would be the point 0, 5. And then to find our x-intercept, we would take a similar approach, except now we'll substitute in 0 for y, because we want to substitute in for the other variable. which will leave us with negative 5x is equal to 40, and then dividing both sides by negative 5 will give us x is equal to negative 8. So our x-intercept in this case will be at negative 8, comma 0. In each case, just to reinforce it one more time, whichever intercept we're trying to find, we set the other variable equal to 0 and solve for what's left over.